Good night, good night, good night. I'm hoping that my panelists can hear me. Let me
Yes,
hear.
sir.
All right, great, good job. So, good night to everyone. I hope that you are all well and that we are preparing for our exams. So, I see Dukan, I see Gray, I see Vassal, I see Musically X, Amari, I see who is this? King, Mitchell. I'm seeing Morris and Marlo, Simmons, and a whole host of other people who are joining in here. Thank you all for joining. So, for this evening, quick session, we're not going to stay long. So, let's get to a few things here quickly. All right, let's go with this. We know that as we prepare for PEP, especially the ability tests, um, we know that we have questions that have to do with verbal reasoning. Okay. We know we're looking forward to seeing analogies, antonyms, synonyms, homophones, homonyms, comprehension type questions that may be based on some given scenario. We have logical reasoning to do. We're looking for like sequencing, looking for a pattern, looking for that rule to extend a sequence. Quantitative reasoning is reasoning that has to do with what? Numbers, what operations are needed to solve something, what steps do I need to take. Those are some of the questions we have to look at. Remember to read the question more than once. Pay attention to important words that may be in bold letters or underlined. One missed word can change the meaning of an entire question. Remember to use the process of elimination and to check to see if your answer makes sense, if it makes good sense. Okay. Now, here we go. This one is for YouTube. First off, YouTube people, round of 138 to the nearest tens. So 138 to the nearest 10. That one is yours. Okay, see several answers coming in here. All right. Let me just set up something here. 130. All right. I am hoping that my camera will be able to see all of this here. And let's go. Let me see if I can pull my camera up for you. Let's go. Camera, camera, camera. Where are you? Here we go. Let's see. And let me swap this one out. And here we go. Switching. Let's go with this. So if we are going to round something, all right, I'm seeing 140 and 140 would be correct. Let's say that this is the number 130 and this is my lower band. And I have all the way over here 140 as my upper band. And the number 138, I am saying that 138 is actually closer to 140 than it is to 130. All right. I'm hoping that you could see all of that in one go, but doing the best we can here. Okay. So that's what rounding really is. Seeing how close the number that you are rounding is to some band, a number that is lower, in this case, the 10 that is below, or the 10 that is above. Okay. So remember rounding, and we have two general groups. We have our rounding up group and we have our rounding down group. Let's hear from the people YouTube. Let's go with our rounding down group. What are the numbers that would be in our rounding down group? And then what are the numbers that would be in our rounding up group? Okay, let's go. Okay, so I hear 4 and below, but musically, you don't tell me 4 and below for which one. All right, I see 1 to 4. For up, still waiting on a below 5 for which group? Okay, I see 5 plus for the rounding up. So you would have 5, 6, 7, 8, and 9. Those would be in that group. And then 1, 2, 3, and 4 are going to be in this group. Okay, so based on the fact that we have an 8 here and we had 138, we're going to round up to the next number that we're focusing on. So if it's to the if it's a tens, then we're going to look for the next 10 and go to that 100, thousands, whatever it is. All right. So I hope that helps. What do we call this though? When we're thinking of the quantitative topics, there's a topic that we use with this. There's a word and a e word that this fell under. Tell me what those words are.
Sir, panelists?
Pardon me?
Is it the panelists who should answer?
No, I'm waiting for our people on YouTube, giving this first one to them. Let me switch back here. One, an A word and E. Estimation, well done. Let me get this on screen here. Let me see if I can show this musically. Had it here. She was the first. Well, Willie also had it, right? Estimation. The A one, no, I'm looking for that one. Yes, says I have estimation here. Let's go with estimation here again. Looking for the A version of that word. Let's go here. I'm seeing an answer. Approximate or approximation. Approximately. All right. Those are some words that could also fit into that idea of not giving an exact figure, but getting close to it by rounding. Okay. All right, cool. Thank you guys for that one. All right, so let's stop the cam. Let's go over to our panelists now. And this one is for the panelists. Panelists, let's look at this. If I have 2, what would 2 be equal to? 2 whole. As a fraction.
Sir,
All right, go ahead, sir.
would it be 20 over 10?
20 over 10. And what would you do then to get that 20 over 10 to actually look like 2?
See how many times 10 can go into 20, which is 2, so you would only have 2 whole.
All right, excellent work there. Cool. Let's go to the next one. Let's hear from our friends on YouTube. Name the highest common factor of 16 and 40. This one is for YouTube, 16 and 40. All right. Let's go here. Quite a number of correct responses. Too many for me to take. But Ajani, Vassal, uh, Grant, Willie, Zeph, um, Tess. Tess has it as well. Abraham, Santoki, Kuri. Let's see. Several. All right. Rose. They all have it. Murray has it as well. Um, let's go. Let me see if I wanted to find the highest common factor. How could I actually set that out? If I wanted to find the HCF, what could I do? Panelists, tell me a strategy, and then let's see if we can put that on paper.
Sir,
Okay, go ahead.
you could list out all the factors of both numbers and see which one is the highest. Compare all of them and then see which one is the highest.
Interesting. You want me to do some listing there. Let me swap and see if we can get this one going. Let's get this. So you want me to do some listing. So you're saying I need to list out all the factors of 16 and then the factors of 40. That's what you're saying. So what are the
Yes, sir.
factors? Let me see if I can bring this over some more. Factors of 16. What would those be? So let's put 16 on our paper. Factors of 16, I'm going to use the method of closing. So I'm going to put 1 here and 16 over the other
16.
side. Okay. Let me see if I can bring this up a little more. 1 and 16. So then 2 and what?
8, sir.
2 and 8. Then what?
4.
Then 4. So the factors of 16 would be 1 times 16 giving us 16, 2 times 8 giving us 16, and 4 times 4 giving us 16. What about 40? Again, 140.
Yes, sir.
Then
And
what?
2 and 20.
2 and 20. Yes.
4 and 10.
4 and 10. Mm-hmm.
5 and 8.
5 and 8. Any factors between 5 and 8 that could go?
No, sir.
What are the factors between, what are the numbers between 5 and 8?
6 and 7.
And they can't go into 40 without leaving remainder, so we won't consider those as factors.
Factors.
Cool, let's go. So if we're going to use that now, then we need to say what are the common factors here. We see 1, we see 2, we see
4
4, we
and
see
8.
8. All right, so then we could say the highest common factor would be 8. Okay.
Yes, sir.
All right, that's one way of doing it. Is there any other way of doing this? Anybody knows any other way?
Sir,
Yes, go ahead.
sir, maybe you could use the L method, sir, like to see which number can go into them, sir.
What we call that? Though I have another word, another
Sir,
phrase.
prime factorization.
Oh, we could factorize those then. All right, let me see if we can get that done. So what I could do, I could then take our 16, hopefully it will hold here, and I could factorize 16 and I could also factorize 40. All right. So now I could say 2, smallest prime, 2 into 16 would go how many times?
8 times.
All right. And then 2 into the 8 would go?
4 times.
All
4
right.
times,
Since it's even, I'm going to continue with 2. 2 into the 4 would go?
2
2
times.
times,
All right. 2 into the 2 here would go?
1 time.
Let's factorize the other 40. 2 into the 40, starting with the smallest prime again. Would go?
20.
Would go how many?
20 times.
Oh,
20
20.
times.
Cool. 2 into the 20 would go?
10 times.
10. 2 into
10
the 10 would go?
5 times.
All
5
right. And
times,
5 into 5. All right, 1. Cool.
1.
Let's go with this now. So I would list the factors of 16 now. The prime factors. So 2 by 2 by 2, 1, 2, 3, 4 of them by 2. So 1, 2, 3, 4. Cool. And then listing the factors of 40, these 2 by 2 by 2. So 1, 2, 3, 1, 2, 3 by 5. Let's go. We'll take this pair, 2. I'll take that pair, 2. I'll take this pair, 2. These I can't keep because they are not an even pair there. So my highest common factor would be equal to 2 times 2, which is 4, and 4 times 2, which is 8. So my highest common factor is 8. So listen to this. You can use the method here of listing, right? And it's good and it will work. But if I were to say find the factors of 1,240 and 2,400, the highest common factor of those, this listing method could take quite a long time. Okay. I see Kaden saying we could also use the factor tree. Yes. The factor tree could be used to replace this. I just like the ladder because to me, that's what I like. Okay. So but we could here use this, right? Kaden is also saying we could use the factor tree, find those prime factors of 16, find the prime factors of 40, pair off those things that are common, multiply those, and then we could get to what? Our highest common factor being 8. When is this necessary? This could be used when we are doing what? Let's go. 16 over 40. When we are what? Somebody from our panel?
Simplifying factors.
Simplifying fractions. So now, since the highest common factor we know here to be 8, and I have 16 over 40, now I could say what?
8 into both of them.
So 8 into the 16 goes 2 times, and 8 into the 40 would go what?
5 times.
5 times. Some people don't like when it's set out like this because they don't see it. So let's put it another way. We could say 16 over 40, and we could divide this by 8 over 8 like this. And we would say what? 8 into the 16, 2 whole times, and 8 into the 40, that would go 5 whole times. So, some people they see it like this. Some people they don't see it ready like the other way around. All right, some people from the panel falling off. Let's bring them back. So I hope that we are all clear on that one. Okay. All right, great. Let's go back to our slides. Let's get another question here. Here's another interesting one. If 0.8 means 8 over 10, what is 0.9? This one is for our friends on YouTube. Let's give our friends on YouTube the opportunity to do that one first. Let's go. All right, so that would be 9 over 10. 9 over 10. Excellent work. And we're looking at place. Just before that, is this larger than 1 or less than 1? Larger than 1 or less than 1? 9/10.
Less than 1?
It's less
So
than 1.
less.
Which one is larger, the 8/10 or the 9/10? Which one is
9/10.
9/10? So 9/10 is, if we were to put that on a number line, 9/10 would actually be, and I'm noticing that in preparation for the PEP, we're noticing the number line coming up a lot. So we need to be able to place things on a number line. So 9/10 would actually be closer to 1 than 8/10. All right, let me just make up one off the top of my head right now. Which one of these would be closer to 1? Would it be 9/10, 8/10, or 2/10? That one is for
9/10.
panelists. The 9/10. Which one would be closer to 0?
Sir,
2/10.
The 2/10. All right,
2
cool.
10, sir.
Very good, very good. So we have to be able to place those. Okay. All right. Let's see. This one for our friends here on the panel. 1.6 if we wanted to express that as a fraction, some fractional number, how what could we say?
Sir, 1 whole and 6/10.
1 and 6 tenths. The one there on the what left of that decimal point would represent the whole,
Whole number.
and the six after the decimal point or to the right of the decimal point would represent that portion that is what, a fraction. I'm seeing here, let me take Willie's answer and just put it up here for all of us to see. So she has, well, I'm not certain if it's she, but let's say Sam Sam. All right. 1 and 6 tenths. All right, cool. And I see Pine. Let me see, where's Pine? Pine had it as well. Thank you. There we go. All right, cool. Let's see. Let's continue. Um, Here we have this one for our friends on YouTube. Order the following: 4.0, 3.9, and 4.9. And I want these in ascending order. And ascending order means from, let me hear from our panelists. Samoya, ascending means from what to what?
Yes, sir.
Yes.
Sir,
Ascending,
can you repeat?
what does ascending order mean?
Sir, from largest.
Ascending?
No, sir. Sir. Oh, ascending, sir. It means from the smallest number to the largest number.
All right. And I see Samsam saying in the chat, Samsung is a girl. Sorry, Samsam. All right. Hard to tell sometimes based on the handles that you people have. All right, so let's get here. Let me see. I see Dukan. Let's pull Dukan in. So Dukan says 3.9, then 4, then 4.9. Panelists, do you agree?
Yes, sir.
All right, cool. Let's
Yes,
take
sir.
let's take
Yes,
one.
sir.
Let's take one for the panel now. Panel, which of the following is not a square number?
Sir.
Hold on, hold
Sir.
on. Hold on a second. Let me pull this down here. Not a square, not a square.
May I
Sir.
try?
Can I
Let
try?
me hear from one
Sir.
of the ladies. Brianna,
Yes, sir. I would say 12.
you said 12? Why you would say 12? Out of all I number them up there, so why you have to go choose 12?
Yes, sir, because 3 times 3 is 9, and 4
Mm-hmm.
times 4 is 16, and 5 times 5 is 25, and 12 is not a square number.
Why, what makes a square number a square number? Just out of grand curiosity. What's so special about this square number?
Sir, when two same numbers are multiplied by itself,
I see. So the squared is what? Actually multiplying what? Two factors, two same numbers, and
yes,
we
sir.
get it. Could you give me the square from someone there has getting a little feedback there. So
Sir.
listen to StreamYards and not YouTube. And try to keep the background there quiet. All right. Let me hear from Bree. Bree, give me the square numbers from 1 to say 12. Go ahead with that.
Yes, sir. 1 squared 1, 2 squared 4, 3 squared 9, 4 squared 16, 5 squared 25, 6 squared 36, 7 squared 49, 8 squared 64, 9 squared 81,
Mm-hmm.
10 squared 100, 11 squared 130, wait, 11 squared 132, and 12
Mm-hmm.
squared 144.
All right. Um, yeah, that sounds about right. Let me go. Let me go. What was the 11 one again? I'm almost certain I heard 132.
122.
22.
Sir, it's 121.
Oh, okay, okay. All right. That sounds a little bit better now. So just that we're sure. All right, cool. So for the most part, what about 13? Anybody remember 13?
Yes, sir. Can I?
Sure. What's
Yes, sir.
13?
Sir,
Mm-hmm.
for 13, it's 169, sir. For 14, it's 196, sir. And for
Wow.
15, it's 225, yeah.
Oh, yeah, sure. I found that
Sir,
one.
and
Sure.
for
Sure.
16, it's 256.
All right, cool, cool. Una take time now. All right, good. So we have our squares memorized up to about 16, so that if they ever ask us in the ability test to work with any square numbers or to complete a sequence using square numbers, quick, I know from 1 to about 16. And if I needed to find anything beyond that, I know that it would be a factor by a factor giving me that squared. Okay, so for example, we have the 9 nines, and we know what that would be. We have the 12 12s, we have the 13 third, and so on. Okay, cool. All right, let's have another one. Wow, this one is interesting. This one is for our friends on YouTube. Let's go with this. Um, if there are 90 marbles in half of a box, how many marbles would be in a quarter of the same box? YouTube people, that one is yours. Miss Miss Chrissy, take time with me now, sir. Miss Chrissy just a deal with it strong. Just like wow. All right, let's see. Let's keep her answer up. Let's go. And Grant and Morgan and Leonie and Brian and others have a response there. Ford, what you're thinking? Tane, how we work this one out?
Sir?
Mm.
Okay, so half of the box would be 90.
Hold on, let me see if we can get this up here. So I have let me see. You know my drawing was so good already. So box. Mm-hmm. You say half of the box. Yes. And I must put in how much? 90. Good.
90.
Yeah.
Sir, so you could find, wait. So if half of the box is 90, you would
Mm-hmm.
find a half of 90, which is 45.
So you're saying a half of a half is a
Two
quarter?
halves make a, two
Oh,
quarters, I mean, make a half.
oh,
And two
or
quarters make a whole.
okay. So that means that this would actually be what? 45 and 45, and this really would be 45 there, so and 45. So all of this part is actually what? 90.
90.
All right, so let me switch this round on you then. How many marbles would be in all of the box?
How many marbles would be in all of the box?
Mm-mm.
180.
Okay, because we'd have 90 here on one half and 90 on the other. Good thinking there, like that. Let me see here. No, I saw something by Blake. Let's get Blake. Blake is saying 90 times 2 is 180. 180 divided by 4. Whoa, love that, Blake. Would be the 45 as well. Great. Great thinking and explanation from both sides. Aha. Wait. You're not seeing this one. Let me pull this one back. Here, let's go. So here we have this one for our panelists. Maxwell got 75, 65, and 85 on 3 tests. I'm missing an S there, please. What is his average mark?
Sir, may I try?
75, 65, and 85. What's the average mark? Go ahead. Tell me what you're doing.
So, sir, to find the average, sir, first you have to add up all of the numbers and divide it by the number of addings, sir.
Okay, hold on. So let me take time. 75 and then 65 and then 85, you say? And we're going to add up all of those. So 5 and 5 and 5 is 15. I must write 5 and carry 1.
591.
And then 8 and 6 is 14. 14 and 1 is 15, right? 15 and 7 is 22. What's the sum that you get?
Sir, the sum that I get, sir, is 225.
Oh, so now I need to divide the 225, you say. By how
By
many?
three.
By
Three, sir,
three.
because you have three grades.
Okay, hold on. And when you're finding the average, what you need to do again?
Sir, you add up all of the numbers and divide it by the amount of add-ins.
Okay. So let me see if I get this now. So you're going to say 3 into 20. How many times that would be?
Sir, can you repeat?
Help me now, help me. Help me with this one. Where do I go now?
Yes, sir. So, sir, the answer that I got, sir, is 37, 35, 75. Oh
But
God.
help me. See here something if you divide this by 3, so help me.
Yes, sir. So, sir, you
Huh.
could
Can
3.
3 go into 2?
No, sir.
So 3 into 20, 22 then. How many times?
Sir, I can't hear you that properly.
All right. Hold on. Let's work. Let's work. Not certain what's happening to my connection here. Let me bring back Tess then. Tess, can you hear me clearly?
Yes, sir.
Sir, are you hearing me?
I
Yes,
can
I'm
hear
hearing you
you.
now. I'm hearing you now. So 3 into the 22. How many times would that be?
Sir, yes, sir, would be 7 times with a
All right.
remainder
Hold on.
of one.
So 7 times the 3 would give me 21. And I'm going to subtract now. If I have 22 things and I take out 21, I have one left. Um, I'm done, right? No?
Yeah.
Missing
No,
a step.
sir.
What step am I missing? I need to do what?
What I said, sir,
What step am I missing? I need to.
bring down
Good. And now I will say 3 into what? 3 into
3 into 3 into 15, sir.
5 times 5 threes would give me 15. Subtract again
Mm,
15 things. If I have 15 and I give away 15, I have none left.
0.
So my answer would be 75.
5.
Clear on that? So
Yes, sir.
give me a statement about Maxwell's average mark.
Yes, sir. So, sir, the Maxwell average mark would be 75.
All right, cool. Great. Even though we're not doing the performance task just now, it's always good for us to be able to what come up with a statement. Let's go. Haha. What about this one? People on YouTube, here is your question. Let's go with this. A leap year happens every 4 years. If the last leap year was in 2020, when was the leap year prior to and after the stated year?
May I try, sir?
No, no, no. This is for the YouTube people. So I'm seeing Sterling, you have one. Okay, I see both of them now. All right, I'm seeing Sterling. Let's see Sterling's response. It's running away from us. Sterling says 2016 and 2024. Panelists, do you agree?
Yes, sir.
Yes,
Why?
sir.
Yes, sir.
Explain,
Because,
explain.
yes, sir. May I explain?
Sure.
Yes.
Go ahead, Tess. Let's hear from Tess.
Sir?
Sure.
Yes, sir. So prior means before. So the
Mm-hmm.
stated year was 2020.
Sure.
So, and it says that a leap year occurs every 4 years. So
Mm-hmm.
to know what was the leap year before 2020, we'd
Mm-hmm.
subtract 4 from 2020 and we'd get 2016.
Mm-hmm.
And to know the leap year after 2020, we would add 4 instead, and that would
Mm-hmm.
give you 2024.
All right, cool. I noticed that you use multiple operations here, but they never told us in the thing that we should do any adding or any subtracting. What did you have to do to figure that out?
Sir, they
Was it?
wanted to know two things.
Mm-hmm. So I just
So
want to
which
hear that
means
you
I
had
would
to
need to use
apply.
two different operations.
Good. You had to apply
Yes,
some
sir.
what?
I would apply the subtract and addition because
Mm-hmm.
those are the opposites, and
Mm-hmm.
before and after are also antonyms. So that came to me that I had to use two different operations to find
Very
my
good.
answer.
I love your thinking on that one. All right, cool. Great job there. All right, so let's, I think this one should go to the panel. Let's go to panel. Ah, here is one for the panel. What is the difference between 5 squared and 7 squared? All right, you panelist people, the other just a few moments ago were showing off your squared skills. So what's the difference now between the 5 squared
Sir,
and 7 squared?
sir, may I try?
Sir, may
Sure,
I
go
try?
ahead. Let me hear from Tane. Go ahead.
Yes, sir.
Mm-hmm.
So the difference would be 24. How I figured
24.
that out?
Hold
I
on, hold on.
squared 5.
Let me get my paper going here. So yes.
I squared 5 and got 25. I squared
Mm-hmm.
7 and I got 49. I took away
So
27.
25, yes, sir. And
Yes,
7
from
squared,
49.
49. Mm-hmm. And you
I took
subtract.
away 25
What
from
tells me that I
49.
need to do some subtraction? Why is not a plus?
Difference?
Oh, different. That key word. Okay, all right, cool. That signal word difference. So now help me. What else do I need to do now?
5 from 4. 5 from 9 gives you 4.
Okay, because 4 and 5 make 9. Cool.
9.
And then
2 from 4 gives you 2 because 2 and 2 makes 4.
all right. So the difference would be 20.
4.
All right, love that. Good. Easy reasoning there. Let's
Sir, and in the statements also, sir,
see.
it also says between, sir.
Mm-hmm. All right, fair enough. Thank you for that one as well. Let's go with, do I have any more questions here? Coming close to the end. This one is for our friends on YouTube. I think this is the last one. Which of the following letters, are not symmetrical? Let's go. So symmetry, symmetrical. I seeing a whole lot of answers flying in here. Leonie. You only need to say it once, guys. All right. So panelists, let's see. Let's take Alicia for example. Grant says the letter F. Do you agree?
Yes, sir.
Why?
Sir,
What, what,
because
what does symmetrical thing mean? Just out of grand curiosity.
Yes, sir, I agree.
What does symmetrical mean?
sir, yes, sir,
If it can be
symmetrical
divided in equal parts?
equal parts.
So you can divide A into equal parts?
Yes, sir.
Hold on, you tell me how you can divide A into
It
equal
has
parts.
a vertical line of
Sir,
symmetry.
Oh, so if I
One
were to
line
put
of
a
symmetry.
vertical line, I could get A into 2. What about B?
It has a
Letter B.
horizontal line of
Horizontal.
symmetry.
Okay, so all right. C,
A horizontal line of
Horizontal
symmetry.
line of symmetry.
D.
Sir, I'll say horizontal line of symmetry.
What about E?
Sir, it have a
Has
horizontal line of symmetry.
All right, let's try. Let's try with F then. Can I get a horizontal line out of it?
No, sir.
What about a vertical line?
No, sir. Sir, if you cut it into a vertical,
Go ahead. I'm not hearing you.
yes, sir. If you try to cut F vertically or horizontally, sir, you
Mm-hmm.
won't get equal parts, and we are trying to get equal parts that will match with the original figure or shape.
All right, thank you. Good explanation there. Here we go. If Tommy is 3 times as old as Martin, who is 2, how old will Tommy be in 6 years? That's open. Anybody can try that one.
Yes, sir.
All right. Let me
Sir?
hear
Sir,
what you
may
are.
I try?
All right, Tess was first. Let's go, Tess.
Yes, sir. So it says that Tommy is 3 years is 3 times as old as Martin, who is 2. So
Mm-hmm.
Tommy would be 3x, and we know that x would be 2. So Tommy would be 6 right now. And
Mm-hmm.
it says how old will Tommy be in 6 years? So that's
Mm-hmm.
future. So it add 6 plus 6, which
Mm-hmm.
the 6 that would be Tommy's current age, and the 6 that we want to know what is his future age. So 6 plus 6 will give us 12 years old.
So Tommy is 12 years old. All right, last
No,
one.
sir, he will be 12 in the future in
12
six
years
years,
old. In
but
6
he's
years,
6
he'll be
right
12.
now.
He's 6 now. All right. Good reasoning there. Last one. I think this is the last one. Here we have a calendar, and our question is, when will the 26th be? When will be the 26th? On what day of the week will the 26th be?
Sir, on
Sir,
a
may I try?
Wednesday.
On a Wednesday? Let me see.
Yes,
Let me
sir.
see. Let me get this down here. Let me see in the chats if we have anybody else. Somebody saying a Thursday, somebody saying a.
Yes, sir. Agreed. I agree with Wednesday.
All right. Let's
Yes,
go.
sir.
What is the pattern? Is there a pattern that we can establish?
Yes, sir. They're adding 7 each time.
Okay, hold on. So if over here, oh no, I can't add it like this. Let's see. Let me try to escape here and make this a little smaller. We have to wait on it. Okay, let's go here. Maybe this will help. So, um, good. Let's see if we can add. So the 9 and the 7 would have given us what?
16,
16. 10 and 7 would have given us.
17,
17.
And this would be what?
18.
18. Hold on. Not working. Doesn't want to work with us. So this would be 18. Um, Going all over the place. 18. Let's go. And then we have 19 here.
Yes,
19.
sir.
Let's just jump ahead. Somebody said it would have been a Wednesday. 19 and the 7 would have given us what?
26.
26. Is this an important date?
Yes, sir.
What date is this? Is this?
Our PEP exam.
All right, cool. So
Sir.
this was the last question for you guys. I hope that you see that the calendar has a pattern to it. We add by 7 if we're going vertically like this. All right, guys, thank you for your participation. We did well. We did about 50 minutes here. Thanks again. Hold on, let me get for you that link. We want to do a quiz with your questions that you come up with, right? So let me just get that link and drop it in the chat, and you are going to add your questions there. Still want a few more questions to make it a good experience, so we'll try that later. Later this week. So give me just a second here, and let me get the code for you. Here we go. I'm gonna copy this. I'm dropping it there now. Here we go. There it is. That's the link for you to add questions so that we can enjoy a nice quiz. All right, guys. Thank you. Time well spent, I think. Thank you, thank you, thank you. Take care, and I will see you in our next episode. Bye, guys. Have a good night.
Goodbye, sir.
Bye, sir.
Bye bye.